Although accessing the Arduino input and output pins is trivial through our Arduino sketches, it is useful to know that these pins are also available through Linux. Unfortunately, the process of accessing the Arduino header pins through Linux is by no means trivial. In this lecture, I'll give you a demonstration of how it can be done. Keep in mind that the process can be made easier through the use of specially designed Python libraries. However, at the time of creating this lecture, I have not been able to find one that I felt was good enough to include here. Let's have a closer look. In this lecture, I would like to give you a quick demonstration of how you can control the GPIOs on the headers of the Arduino Galileo 2nd generation from inside Linux. The GPIOs are accessible through Linux instructions, but the thing that makes the process slightly complicated, at least when you compare it to how you do things via Arduino sketches, because these GPIOs are multiplexed. So each one of the GPIOs as seen in Linux are associated with multiple functions, not just a single function as in the case of the Atmega, where you have one GPIO that has a single function, a single pin controlled by it. The documentation on this topic is slightly sketchy, so the best I was able to find was this post at mutexlabs.com, and it shows you, see if I can get rid of this social bookmarks thing, I can't unfortunately, shows you the pin configuration options for the Galileo Generation 2. Most of the tables that I've been able to find are for the first generation of the board. They don't seem to correspond precisely with the second generation. So I'll go with this table here. You have the shield pin in the first column, so IO 0, 1, 2, 3, etc. So these are the digital pins on these two headers. And then you have the various functions that each pin performs. So you can see, for example, that IO 0 on the shield has got 1, 2, 3, 4 functions, multiplexed to 4 functions. The one that I'm more interested in I'll be using in this demonstration is IO13, which acts as GPIO and SPI. Linux sees it as GPIO 7. However, because it's multiplexed, I haven't been able to find a direct way to access it by just accessing GPIO 7 on Linux. Instead, I have to set up GPIO 30 and GPIO 46, which if I go up, you can see that these are GPIOs as seen by the level shifters on the board and the multiplexer. So I'll show you the process. Let's go to the Linux side of the board. I'm connected to the board via the serial to USB connector. And let's say that I would like to turn the onboard LED, which is connected to shield pin number 13. I'd like to turn that on and then turn it off again, but to be able to control the LED on the board. So look through the table here, the mappings table, and you can see that IO13 is multiplexed via GPIO 30 and GPIO 46. So the first thing that I want to do is to export these two pins, these two GPIO pins, so that I can control them. So first GPIO 30 and then GPIO 46. Now I'm able to write to those two pins. First, I'd like to set the value of GPIO 30 to 0. So 0 would mean that this level shifter goes low and it allows me to control its direction. So direction will be out, and that's why I'm going to use echo to send or to write the 0 value to GPIO 30. GPIOs can be configured by writing values to several files, and those files are located under sys, class, and GPIO. And in here, you can see you've got all the GPIOs available. The one that I'd like to write value 0 to is GPIO 30. And inside GPIO 30, I've got another bunch of values of files that I can interact with. And one of them is value, this one here. So I'll say value. And now the content of, let's check it out, the content of this file that controls the value that is written to GPIO 30 is GPIO 30, and the value is 0. Okay, so I've set GPIO 30 to low. The next one, let's go back to IO 13. The next one I need to deal with is the multiplexer GPIO 46. I want to set that to low, so multiplexer 1. So I'd like to set that to low, and when I set it to low, you can see from here the way that it corresponds, I'll be able to access the pin 13 here and not the SPI clock. If I set it to high, then I'd be able to access the SCK pin for SPI. So let's go and configure GPIO 46 to be an output so I can control a LED connected to it. So I'm going to make that, I don't need the N, I'm just going to make that an out. And that goes to sys again, class, GPIO, then GPIO 46. In this case, I want to control the direction. So the direction for GPIO 46 will be out. I'll just fix a typo here. Okay, done. And now, see that because I've set the direction, I already had the value for GPIO 46 to 1. So the onboard LED connected to pin 13 is already on. I can verify that by checking out the value that is connected to GPIO 46. So check out the value. Sorry, 0. I'll take that back. So 0 is high. And if I change that to a 1, the LED should turn off. So just store value 1 to GPIO 46 value. Okay, so I saved value 1 to GPIO value 46 and the LED is now turned off. And I can turn it back on by changing the 1 to a 0. There we go. So you could use this process in any program that is running on the Linux side of the Arduino Galileo Generation 2 to control the pins on the Arduino side, so the pins on the shield. All you've got to do is to read the appropriate values to the GPIO settings as those are exposed in the file system of the Arduino Galileo. So that was just a quick demonstration of how this is possible.